All right, everybody, are you able to hear me clearly? Should we start now? Hello, Matthew. Hello, Deepak. Are you able to hear me clearly? Great. So let's start. So, what are we going to do first is I've started the recording. All right. So, our first objective is to generate the recommendations. Recommendations is giving suggestions to users based on their past history or the product's history. So the core part of a recommendation is item based user item recommendation, as in we are giving the recommendations to the user based on the history of the user. So the input to our example in this example, the input to our Mahat recommender is three columns. First is user ID. First is user ID, second is product ID, and third is the rating. The rating has to be in between 1 to 5 or 0 to 5. All right. The fourth column, although the example shows 9, 8, but the input which Mahat expects has to be 0 to 5. All right. So we have to prepare the data such that we have user ID, comma, product ID, and the rating. All right. Now let's get started. First of all, before we start, we have to download this group lens data. Group lens maintains a very good open source data on movie ratings. All right. So you can. I'm using a different account here. All right. So is the screen visible or should I increase the font? Deepak, is it okay? Are you able to read what is it? All right. All right. So I'm going to use my own account. All right. So we are going to download this data first. Uh, this data. All right. wget -nc means no clobber, meaning if we have already downloaded, it will not download again. So the data is downloaded and I have unzipped it. Now here you see movies.dat, ratings.dat, and users.dat. Let's have a look at what do these files mean. So movies.dat contain the information about the movies. See, movie ID, movie name, and genre of the movies. Right now we are only seeing the last 10 lines using tail command. Next is we can also see ratings.dat. So if you don't like to use the terminal, you can directly upload this file into the HDFS. Now you can see under the ratings, you have user ID, movie ID, and timestamp. And before that, there is a rating. Interestingly, the ratings are all in from 0 to 5 already. Okay, so now we have got ratings.dat file based on which we will generate the recommendation. Right now we are not taking into account the movie genre and other information. Okay, so you can see that this basically has user ID, double colon, product ID, and then rating, and so the data is separated by double colon. Okay, the data is separated by double colon. Our objective is to convert this into comma separated, and we don't want the last column. Okay, so meaning, if we, let me take it out. All right. Okay, so let's just take this one. All we want is the data in this form: user ID, comma, product ID, and comma, nothing of this sort. So this is what we want to do for all of the data. Okay, so can you suggest a way to do it? Anyone? So how would you do it programmatically? So the objective is to convert this kind of data into comma separated one, and we are going to ignore the last call. We don't want this. All right, we're going to ignore all of this data. So what do you suggest? What should we do? We have got huge data, so this is what we want out of that. Right now I've done it manually or partially automated. So Matthew suggests SED. Okay, Leonid suggests import into HBase with delimiter double colon. Alright. Why do we need to import it in HBase? Alright. So let's first of all let's copy it. I've already copied it. So again let me try copying. Hadoop fs copy from local. Okay. And I'm saying ratings.dat, and these are a million ratings. You can see wc minus l ratings.l data. Okay, you can see that there are 1 million, more than a million ratings. Okay, so Hadoop fs copy from local, and we are copying ratings.dat to our hdfs. Okay, it says file already exists. No worries. So we already have a file in our hdfs. Okay, perfect. Matthew suggests that can we do it through pig storage? Brilliant, brilliant. So one suggestion was through SED. That's also correct. The only thing is using SED unless you use Hadoop streaming. Unless you use SED with Hadoop streaming, you will not be able to do it using a Hadoop. Okay, if you are using SED locally, it might hit one of the servers, which is not a great idea. All right, and if there's a huge data and you want to do cleanup or churning, it makes sense to go with tools like Pig. All right, so let's load it in Pig. So keep all of you when you are, so what Matthew is suggesting that use pig storage. The only downside of pig storage right now is it cannot take two characters. It can take only one character. All right, it can only take one character. All right, so keep suggesting what kind of pig script you will write. This will help you refresh. So can anybody suggest what should I do right now quickly? Yeah, yes. So we can run pig command. All right, All right. Matthew suggests that can we run it through twice? Maybe, yeah, maybe. Yeah. But even once is sufficient. I'll show you how. So let's say we load our data using load command and say ratings.dat. All right. Using using pig storage, and we mention single column. All right. And let me try to say we'll run everything on sample. Okay. We'll run everything on sample, and s equals to not sample, we'll just say limit a 10. So Leonid is suggesting, can you use scoop to import? For scoop to import, we'll have to put it in some database. Okay, let's try to see what is there in s. Dump s. Okay, so it's doing, by the time it finishes, so what we have written just now, we are saying, it says we made a mistake. It says ratings.data. We had to say ratings.dat instead. All right. So for me, Asma, so the Unix way could have been that we take this data, pass it through awk, and then save it. But that is not good idea. Reason being, this will be run only on a single machine. Not, it will not utilize the data locality. Here, if our ratings file goes beyond a certain limit, then it's better to use uh, MapReduce. All right. So here, let me just, okay. So sorry, we have to go into my CD folder. Now we are loading ratings.dat into RD. Next we are doing is, for each of the row in RD, we are going to only pick up 0th, 2nd, and 4th. Anybody, any suggestions? Why are we using 0, 2, and 4, not 0, 1, 2, 3? So yeah, so first column would be empty. $1 will be empty because our record, if you see, these are the records, and we are saying split it based on this. So if you see this, there'll be two tabs here. So they'll have to take 0th, and the first one is empty, second one, and then fourth one. All right, and this has to be ignored. Make sense, Matthew? Matthew is suggesting, if you asking if you define a scheme for pig, will it take out the timestamp? Not really. We'll have to remove it by ourselves. Okay. So you see, now we have CD. Now let's have a look at it. Let's try to save CD into something called CSV. All right. So it says that the output directory already exists. Let me delete ratings.csv. All right. Now it's storing the data. All right. Now let me go to not this. We will go to hue. All right. So Leonid, the third column would be empty instead of the column. All right. Let me go into my folder. All right. Here you will notice, if you sort it by date, So this is the folder. Under this, you will see it has cleaned up our data. Everybody comfortable with this? How did we do it? We loaded into pig storage by separating by a column, and then iterated over the records and picked only 0th, 2nd, and 4th column for each record. And then we stored the result into this folder. Okay. Also, I mean, this is basically a folder name. There was no need to put .csv in it. Okay. Now we can start the recommendation. So here is our very simple command line which will do the job. Let me first remove my old previous folders. All right. Come out of come out of this, right? Now, next thing I'm going to do is I'm going to remove the sgiri/records as well as temporary folder created by Hadoop in HDFS, because every time we run Mahat create these folders. One is output folder, other is temporary folder. Next is that we run the recommendation. Now let's have a look at what's going on with this command. This slash means we can break a single line into multiple lines for a command if you want to. Now have a look at this. What exactly are we doing here? We are saying Mahat run item based recommendation using this algorithm. This is our input file and this is our output file. Alright. Now this is our input folder essentially. It looks like a file here because we have named it that way. So this Mahat command is nothing but a small wrapper around Hadoop command, Hadoop jar command. So internally it will run Hadoop jar command multiple number of times. It is basically sort of a launcher of Hadoop jar. Alright, I'll show you this. Now this command is, let me go to the terminal. Now we're going to run it. So it says Mahat is not installed. Alright, Mahat is installed on. So you can switch between the servers by SSHing from one terminal to another. Alright, now here Mahat is installed. It says Java variable not set. Let's set the Java variable. This is where we have installed our Java. Let's start that. So it's launching, it will finish its work and will save the result into HDFS. Okay. So the result will be in a folder called records. So earlier this is where we had stored the data. So yeah, it'll take around 10-15 minutes. It will take around 10-15 minutes to finish this. Alright, again coming back to the point, if you try to generate the recommendations for these 1 million record using any other tool, it might take hours or it might take a long time to get it done. Okay, so everybody with me? So you should run this whole process by yourself. You should finish this whole process by yourself. Should not wait for me to, you should not just think that you have learned it, because the moment you will start doing it by yourself, you will realize that there is more to it than what I had described in this class. All right. So please, even if you just follow this process step by step, it will be good enough. But make sure you just run through it step by step. The real doubts will only start the moment you start following these steps. So once the Mahat generates the recommendations, this is the kind of results you will get. These are the results from the previous class, and because it will take maybe 2-3 more minutes. So how much time has it spent already? Let me just keep the timestamp in place. So you can see this is the timestamp. I'll just keep a note of this one. Yeah, here, this is the timestamp. All right, this is when it got started. So yeah, so this is the result you will get for this user. This result is saying that for this user, the recommendation is this. Okay, meaning this user will like this product this much, this and this product this much, this product this much. Meaning this user will like 1805 movie 5 and so on. All right. All right. Leonid's question is, can you explain the logic used to get from input to output? All right, that will be a little tricky right now. So we are using an algorithm called similarity log likelihood. Okay. So what are we trying to do in this is we are trying to find similar users. Okay. Based on we find similar users based on number of movies which are common. So if I and Leonid has 10 movies out of 20 movies common, so we both have watched in total 20 movies. If 10 out of that is similar, so our similarity is 10 by 20. If me and Matthew have in total watched around say 23 movies, okay, and number of movies which we like, me and Matthew, is around 20. So me and Matthew are more similar to each other than me and Leonid. Based on this, it will group Sandeep and Matthew together, and then we'll we'll start giving the recommendation of Sandeep's movie to Matthew. Okay, so this is how this works. So it first groups the user into groups such that their similarity coefficient is uh, same. So all the users which have similar are grouped together, similar who are similar to each other are grouped, and we give the cross recommendation. So this is one strategy and is used quite often and is being used in this also. All right, so that's what it is. So it's still running. How much time it is gone? It is started at 21:50, so 6 minutes are already gone. 7 minutes. Great. Now moving on. So this kind of assignment where you see the data is actually fairly small. If you go into here, you will see that the data is not that big. Data is not that big. So this folder, you can see it's hardly 11 MB input data. Okay, but because our problem is complex, the variety, the third V, okay, the third V, again, whenever we talked about variety, it was not only about data format, it was also the problem we are trying to solve. How complex is the problem? When we talk about complexity, it's not only the data complexity, it's also the what is it that we are trying to solve. All right, so that's what it is. Although it's 11 MB in comma separated format, still the complexity of problem is really, really high. Make sense to you? Because finding similar users amongst a set of users is like comparing each user against other user, right? So you have to pick up first Sandeep, compare it with Leonid, compare it with Matthew, then pick up Leonid and compare it with Matthew and Deepak, and so on. So we'll keep on doing it. So Sandeep gets compared with Leonid, Matthew, and Deepak. Leonid gets compared with Matthew and Deepak. Matthew gets compared with only Deepak, and so on. So that way, we prepare. This is preparing the full chart of similarity, and then it will give the will start giving the recommendation. All right. Now it is done. So it took how much time? Around 8 minutes. So from here to here, you can see around 8 minutes and 40 seconds. Yes, there are other algorithms also. You can have a look in Mahat's wiki. There are other algorithms for giving the recommendation, starting with log likelihood, Tanimoto coefficient, cosine, Pearson correlation, and Euclidean distance and co-occurrence. Also, right now we have not taken into consideration the the movie definition, as in the genre of the movie, the year it was released, and so on. Okay, we can take that also into consideration, but that again is a part of machine learning. Now, there are many use cases of Mahat, starting with collaborative filtering, clustering, classification, and frequent item set mining. Collaborative filtering means it mines the user behavior and makes the product related recommendations. Clustering is grouping similar items together. Classification is learning from existing categorization, and then auto categorization is something called classification. Fourth is frequent item set mining. Based on the history of items, it analyzes them and forms the groups, analyzes the groups, and then start giving recommendation that these items are sold together, so buy this one also. So that was our Mahat. So Matthew's question is, do developers write their algorithms for Mahat? No, not in general. Generally, they use Mahat's algorithm. The way we launch the program by generating a set of input data, that's what we do with Mahat. We prepare, we prepare the input data, and then we launch Mahat, specifying all the arguments we want. Okay? It's not really a development library, it's more like an algorithm library. All right. So now we are starting something really, really interesting called Apache Spark. Okay, so Apache Spark is really fast and general engine for large scale data processing. It's really fast as compared to MapReduce. It's around 100 times faster than Hadoop's MapReduce when it's run in the memory, and it's around 10 times faster than the disk. So this is their claims. When I say 100 times faster in the memory means Spark is running in memory while the MapReduce of course run via disk. So it builds on a similar paradigm like MapReduce and is very well integrated with Hadoop and other NoSQLs. All right. Okay, so I think I should have waited for some time to before moving on. So here is one question from WebHub. So a developer will need to be aware of all the algos available in Mahout to know the best that suits the need. Perfect. Yes. 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 That's how it is. So a developer need to know basics about machine learning and basics about the various algorithms available. The best place to get started is the Mahat's homepage. Okay, there is a really good documentation, and also there are many really good crash course available or small documentation like two pagers available all around. But I would strongly recommend that even though Mahat is being rewritten aggressively, their documentation is very valid. Document the Mahat the way it was is still very valid. Leonie's question is, can you write custom algorithms in Mahat? Yes, definitely. You can use the same libraries what Mahat is using because they have done good job. Okay, and so but unlike other machine learning libraries, Mahat does not really provide you a platform for doing the learning the to write your own algorithm from scratch. Okay, though it does provide you some amount of libraries. Matthew's question is, you mean Spark retrieves the data and processes it in RAM? Yes, yes, that's correct. All right, coming back to here. So okay, let me just wait for 1 minute. If you have any questions, if you don't have questions, just say no right now. Okay. All right. I'm okay. I'm hoping that Matthew has a question. Matthew's question is there another tool that can accept customized machine learning algorithms? Yes. There are tools like MLlib, okay, which provides you a bigger framework for doing the machine learning. All right. All right. So basically, when we recently were, I mean, a few years back, some of the researchers wrote a product called Spark, which is basically which basically utilize the memory in order to get you the results instantaneously. Okay, so that's where the Spark comes into play. The it basically assume it's done really well and is really fast. Just that for really huge data, Spark might not be a great solution because it might it assumes that the whole memory is yours, okay, when you are doing something. So it is not a great environment for batch processing. If you have some job which you want to run on the cluster without disturbing the whole cluster, and at the comfortable time in a batch process mode, then MapReduce is still the great solution. But if you want the results right away, this Spark will be a great tool. All right. Now, Leonid's question is, what is the definition of really huge? Okay, so the definition of really huge is very subjective, and so when you are doing a normal processing and your data is crossing few GPs, you will not be able to do much of a processing in on the local machine. Okay, the moment your data starts going beyond a certain RAM size, at that point of time you will start moving towards the cluster computing or distributed computing, and afterwards if the data is going into hundreds of terabytes, then you may like to go for MapReduce. All right, that's what I mean by really huge. So how much RAM suits this Spark? So the thing is that it can run in very small RAM as well, okay, but it all depends on that the performance will be little lower if you are not using RAM, if your data is bigger than RAM or your RAM is smaller. Okay, now the good part about Spark is whatever the RAM is available, it can utilize it, as well as for these tools what matters is how many nodes do you have. In case RAM is not sufficiently available, you put another computer and it will start utilizing them, and you will understand how. All right, Matthew. Now let's go for a little bit quick overview of Spark, and I will instead use the other diagram. Let me just pull out a fresher diagram. All right, let me just take it here. All right, so all right, so the typical architecture of Spark is like this. So Spark can run on Hadoop Yarn, EC2, standalone, as well as on Apache Mesos. So Spark utilizes these kind of resource managers, or you can say distributed operating system kind of models, where Spark runs on top of any of these. And if you are trying out locally, then standalone is good enough. Okay, so Spark can run on the cluster being managed by Hadoop's Yarn, EC2, or Mesos, Or maybe if you don't have a cluster, you can go with standalone. Now, Spark can read the data from HDFS, HBase, Hive, Tachyon. Just like our MapReduce read the data from, help us read the data from HDFS and other sources, Spark can also load the data from all kinds of sources. Now, either we write program directly for Spark core. As a user, either we can directly interact with the Spark core using Python, Scala, or any other language. Okay, like the way we did MapReduce, we could directly write MapReduce for jobs in Java. Similarly, we can also submit our jobs directly to Spark Core. But if we are not so comfortable with the basic programming language, we can use SQL to churn our data, or we can also utilize MLlib, Spark R and SQL we can use on top of Spark. So that means all the R's libraries, R has got one of the biggest libraries in the world in machine learning. So that means all of those libraries can be used on top of Spark. Okay, meaning the limitation which we always faced with R was that the R could not run beyond the size of RAM. Okay, if your data is little bigger, then R was useless. Okay, and that's when people used to hit the bottleneck. But Spark R does not have that kind of problem because it utilizes the whole cluster to execute the the algorithms which are written in R. Okay, so on top of Spark Core, there is something called streaming. If you want to process the data per second, then streaming is a way to go. Then we have MLlib. MLlib is a very powerful machine learning library. It provides you algorithms as well as the constructs. With using the constructs, you can build your own algorithm. Although it provides you the built-in algorithm for all kinds of machine learning jobs, it also provides you the constructs which lets you say vector algebra and Fourier transformations and multiplication of matrix. So those kind of jobs machine learning provides, MLlib provides you as library. So that means Spark is a very robust architecture for for lot of machine learning work. Okay, so given all of this, it looks like Spark is going to is going to replace MapReduce alone. All right, but it won't happen that way because MapReduce has its own usages. MapReduce has its own usages which cannot be replaced by Spark, specifically with batch processing. Good. Let me answer your question now. Now, Matthew's question is Spark R syntax is same as R? Yes, it is. Okay. Now, Leonid's question is MLlib competing with Spark R? No. So, Spark R's users are those users who have been working in R for quite some time, or who want to use specific library of R. But the users of MLlib are the people who are trying to build the algorithms or who are trying to do the algorithms which are not there in R yet or who don't know R yet. Alright, I hope this makes sense to you. So Matthew is asking MLlib is mostly in Python. No, MLlib is in all three languages, Python, Scala and Java. All of these, whether GraphX is a graph database. If you are not aware what does it mean by graph database, it means that you are going to present the full graph. If you have a billion nodes to represent as a graph, then you can utilize Spark to do that. And GraphX has come up with the basic algorithms to process the graph. Okay, things like find out the mostly connected components on the graph that you can quickly do using SparkX. Okay, or compute the page rank given the graph. Okay, the nodes which have more uh, incoming edges, those are more important than the one which have less incoming edges. So these are the ways we can represent a graph, and thus we can compute the page rank kind of algorithms. We can run page rank kind of algorithms using graph X. All right, so that's what it is about Spark. So for installation, you can simply either download Spark, or you can simply download like this, or you can simply run the command line like user lib spark bin spark pyspark, and it will run without any complaints. Okay, so let's try to run it. All right, let's try to run it. So if I say user lib spark, I've copied after downloading data from after downloading data from uh, after downloading this TGZ. I have copied it already for you. Okay, a latest version is also available. I have installed downloaded it my home folder. If you want to use that, you can use that one also. Okay, running it's as simple as unzipping and then run the program. So here user lib spark bin spark. Okay, user lib spark bin, and then we say PySpark. PySpark is a command line just like Python. So this is PySpark. I'll show you Python as well. All right, this is PySpark. Now, if you, I like to show you how does a Python looks like. This is another terminal. Now I can say Python. All right. Now, do you see the similarity? This is Python here, Python 2 dot and this. Okay. So this is essentially, in case of Spark, this is also a Python console because I'm running PySpark. PySpark is nothing but a Python console where anything we do here will be interpreted by Python, and we can control Spark from this command prompt. Let's say we say a plus equals to 2 plus 3. We have written this code in Python. If we say define my function and we say x, and inside this we are saying print x into x, we are defining a function, okay, so which is doing the square of any number you're passing. So this is clear to everyone what I did just now here. So Matthew is asking that does it have to be configured to work with Hadoop? Yes, you need to tell where is the name node, not name node. You have to tell the Spark resource manager, meaning you have to tell Spark where is your yarn. Similarly, if you are intending to read data from HDFS, you have to tell Spark about the name node while launching. All right. Does it use newer version of Python? So yes, it does. It does use. It uses a little bit older version because that's what I downloaded, and it has been compiled against 2.6. The newer version which I have downloaded uses a little newer version, newer way. All right. So is this code clear to everyone, Deepak, Vaibhav? So I said a equals 2 plus 3. So I assigned 2 plus 3 to a, which is 5. I just defined a function called myfunc and run this function. Okay. So Vaibhav, Matthew, Leonid, Deepak, everybody comfortable with this in this piece of code? Right now we are coding in Python. Right now we are coding in Python. Perfect, perfect. So if you all are comfortable with this, then there'll be no problem at all. Okay, and this is probably one reason why I have chosen Python. So I'm defining another function which can return my fun plus 4. Okay, so my fun 1, 4 is equal to, sorry, we have to define it little, because we have to make a call, so we have to put brackets here and we have to pass x. All right, this is correct, right? So unsupported operand types for plus. Oh, correct. So the way we have to define our function is my fun. All right, let me just take it out and make it a little better. So we are defining now my fun here, and we are saying colon return x into x instead of printing. We are defining my fun 1, and we are saying whatever you are passing inside, we will run something called my fun, and then we'll say x plus 1. All right, now let's try to do for 1, and we were supposed to return things which we did not. All right, so we define two functions. All right, so my fun is calling the first one, and then adding 1. So if we say 2, it means 5. 2 is square plus 1, because my fun of 2 is 4. All right, yes, it's a very basic function in Python. All right, so although the things can get complex, but it's probably the easiest way to learn a programming. Instead of getting into the details of classes, objects, pointers, and whatnot, we are simply playing with functions. All right, now we are comfortable with this. Now we'll go ahead and try to understand the concepts with respect to the Spark. All right, so the basic concept, probably the most important concept of Spark is the resilience dataset. Every data-oriented language, be it Pig, be it R, or be it SQL, all of them provide you a way of data representation. In case of SQL, the data is in the form of tables. In case of R, the data which you operate upon is in the form of big arrays or tables. In case of Pig, our data was in the form of big, what we call the sets, the data sets. Okay, so in the similar fashion, Spark comes up with an idea of resilience distributed dataset. The dataset, the basic dataset, which is like a big array, is represented as RDD, and this RDD is actually loaded on multiple machines at the same time. It's loaded over the cluster at the same time. First few elements are in one server, second few elements are in another server, third few elements are in some other server, and fourth one is in the fourth server. That's how the RDD works. So you read the data from, say, in this example, we are reading data from HDFS and loading it into RDD. This RDD has got four machines, first machine having first part of an array. So this RDD is like a big array of elements. Some elements are on first machine, some elements are on second machine, some elements are on third machine, and so on. So that's an RDD. RDD is resilient distributed data set. RDD can be persisted in memory, meaning if one program has loaded something from HDFS, it can keep it in the memory and exit so that other program can utilize that. If one of this node, let's say third node goes down, the data gets shifted to some fourth node, and the user will never know that the data has been shifted from one to another. So it has auto recover from node failures. It can have any data types but has a special data type for key value. So ideally any of the array, this RDD can have anything. Like an array, the way array can have anything in an object, whether string, integer, or a big object inside an array inside an element of an array, in the same way RDD can also have any object. Just that the one particular object of type key value called tuple, if we have that, that Spark tries to utilize it. When we group the data, then that key value can be utilized. We'll talk about it. Now this whole RDD is like data distributed in in the form of an array over a cluster. All right, and it takes care of node failures and everything. So this RDD gives you two operations. Just the way when we loaded data into pig, it provided us with various options such as filter, group by, and for each. In the similar fashion, RDD provides you the functions. These functions are of two kinds, two groups of functions. One are called transformation and other are called action. Okay, so let's first try to build our RDD. Then we will understand what does it mean by transformation and what does it mean by an action. So let's load it. So here what we are saying, lines equals to sc.text file. Sc is your gateway. Sc is your gateway to the Spark context. So if you see here, it shows you welcome to Spark, and then Spark context is available as Sc. Okay, so which means your entry to Spark, interaction with Spark will start at Sc. Rest of the objects will remain as such as of Python. This Sc object is what makes it the Spark shell. Alright, otherwise it's Python. Alright, now let's try to load the data using this. So we have loaded the data at into this file. We are saying line equals to sc.text file, and this lines has got is nothing but a big array. If you say take 10, we are just saying give me the first 10 records. Okay, this take 10 is an element, is a command provided by Spark. Now what did it give? Let's have a look at it. It's an array. You can see the array, the square brackets, array, and u means string. Okay, u means string in Python, Unicode string basically. So you can see that. So each element is a string. This should definitely help you in understanding that RDD is nothing but a big array. Alright, now let's say Are you not able to hear me? None of you? Matthew? Webhav? Matthew is able to hear. Okay. All right. Good. So now you can understand that RDD is nothing but an array which is loaded on multiple machines. So this sentence itself forms the whole basis for Spark. Okay? That RDD is nothing but an array distributed across the network on multiple computers, loaded on multiple computers. All right? If we have an array in Python, all right, if we have an array in Python, like here, if we have an array, a equals to 1 comma 3 2 comma something 10, this is an array. All right, now we can convert this array into an RDD by saying some variable name, whatever you want to call, equals to sc dot parallelize a. Now if you say this, you can see that this array has been loaded onto onto this cluster. We have a question from Webhub that HDFS replicates file. Will it make RDD replicas for RDD replicas for Spark dataset or flat files? Not really. So we are loading the data from HDFS and we are not storing data into HDFS. So RDD will keep its own replica in order to handle the in order to handle the failures. All right. Did I understand your question correctly, Weber? All right. Yes, SC is an object. So using SC, we loaded it, and the AR which is generated by SC is, you can see, it's a parallel collection RDD. It's a newer kind of object, not an array. Okay, on this AR or our lines, you will have to do two kinds of functions. There are two categories of function, like we executed take here. Take brought the data from the RDD to local machine. All right. So there are two sets of functions which are important when we talk about Spark. Okay. Now the first set of functions are called transformations. Transformations do not bring the data back to the driver node. And what is our driver right now? This console is our driver. The console is the driver or launcher, whatever you want to call it. The console is our driver right now. From there, we are controlling our Spark work. We are connected to Spark from that console and are talking to Spark from there. All right. Make sense to you? Now let's say that we had to compute the line length of each element, and we do not want to bring this information back to the driver. We want to do it on the RDD. RDD is not available locally, it's available over multiple machines. It is on multiple machines. So it's not always required to bring data from RDD to local machine. In those cases, we use transformation. Now, important part here is the transformations are of multiple kinds, starting with map, filter, flat map, group by, and many more. Okay, so the most simple transformation is map, which basically translate an object on RDD into another. If we want to translate our array into another array, then we use map. Map function basically applies your function which is passed as an argument to the map function. It applies that function on each element of RDD. Okay, let me show you, then that will make more sense. Let's take an example right now. We have got lines in RDD. Lines are, these are my lines. So we have loaded our big file into the RDD. Now this RDD contains a big array where each element of this array is line from this text file. Okay. Now what we are trying to do is we are trying to compute. Let's say we are trying to find out the length of each line. Okay. Length of each line. So all we'll do is we'll define a function called my len, and whatever argument we are passing, it will return the length of that argument. Okay, let me show you whether this works or not. So if I say Sandeep here, it will give me the line length. You can see that. If I say Vaibhav here, it will give me the number of characters in Vaibhav. See that? All right. So whatever string we pass to mylan is it's just returning a new number. Now the lines, if you recollect, let's say again I'm launching this. Lines is an array. So if we want to compute the uh, length of each of these objects, what we will do is we will run something called lines dot map, and we'll pass mylen to it. So basically this will result in another data set called, let's say we are giving it ll. So what exactly happened just now? Or what will happen if I say take 10? Okay, you can see that it has returned me a new array of elements where each element is the length of the line. Okay, so what exactly is happening? Can anybody help me understand? It's taking this function called mylen. It is running against each object of lines function. Lines function is a big array, and for each element of lines, mylen function is being executed, and the resulting array is being stored in ll. Is it clear to everyone? Those who are coming from procedural background language, this is what it meant by map. Mapping means executing a function against each element of an array. Okay, it's like in a set we used to do one-on-one mapping. It's like that. Is it clear? What does it mean by map here? All right, so let's say we have to square. So every element of ll is line length. Okay, and what we want to do is we want to see that whether what is the remainder after dividing it by 8. Okay, you want to see that which are the lines which are equal to the which do not leave any tab space. So let's say we are defining a new function called called okay, let me just call it tab R, meaning tab remainder. And anything we are passing, we are returning the remainder after dividing by 8. Okay, so tab R, if you pass it 3, it gives you 3, and if you pass it 9, it gives you 1. If you pass 8, it gives you 0. Alright, so let's say we want to just create LLT equals to LLT equals to LL dot map, because line length is the one which contains this array of numbers, and we pass tab R. LLT dot take 10. Sorry, 10. Now you can see that this is our LLT, and LL is this. Just first 10 elements, okay? These are just first 10 elements. Now you can see that when you divide 64 by 8, nothing is remaining. If you divide 25 by 8, the remainder is 1. If you divide 45 by 8, its remainder is 5, and so on. So it has run your function on each element of this RDD. No, map is a function. So map is a function. Again, let's have a look at it. What exactly we did. Right? You can see that. So this is our LL dot take 10. We took only 10 elements out of it, and tab R dot take gave us these result. Not tab R, LLT. These are our variable names. All right. Now you can see that this function called tab R is being run on each element. Tab R is a function, map is a function, LL is a object called RDD. Is it clear to everyone? How did we reach? So Leonid's question is, can we use this? Yes, we can use that. That's correct. Because len is a function. Right? Matthew's question is, okay, but where do the number form LL come from? The LL is something which we did earlier. You remember lines dot map, and then LL equals to lines dot map and mylen. Okay, mylen. This is what we did earlier. So Leonid's question is, can Spark Spark functions only be defined in Python? When you are working in Python console, you can only define function in Python. But two answers. First, using Python, you can call other languages as well. Second, if you are using the Spark Python, then you can, if you are using Scala Spark instead of Python Spark, if you are using Scala Spark, then you can write code in Scala. Or if you are using Java Spark, then you can use Java client. If you are using Java console, then you can use Java Java for manipulating the data. Make sense, Leonid? All right, great, great. Now coming back here. So is everyone with me? Vaibhav, Deepak, Leonid, and Matthew. billionth. All right. In the similar way, there is another function called filter. And what does filter do? It creates another RDD from one RDD where only qualifying elements are kept. From an RDD, it will just pick up only those elements which are being qualified by this function. Let us say, let us say that out of this array, you see this lines array, we want to keep only the items which has length, okay, which has length is smaller than, or let me try to do something. So if you remember lines was a big an RDD array of text, okay, each of lines, I can say lines, lines of text, okay. Now what we want to do is we want to take these lines and we want to keep only those lines which are starting with A or A, small a or capital A, okay. So we can say start, we just giving one this thing. Let's define a function called start with a filter. This is our function. Any line you give it, it will return true or false if line 0 is equal to a, then it would return true. If line 0 equals to a, then it will return true. Otherwise, it will return false. Okay. So this code is clear to you. We are saying start with a. Okay. So when I run this, just to quickly test whether this works or not, I can say, okay, starts with a filter. You can see that Sandeep is not starting with a. This is true. All right. This is true. All right. So this function checks whether a particular word is starting with capital A or small a. All right. Now using this function, we can only keep out of these lines, out of this lines resilience data set, we can only keep those lines that are starting with a. Okay. And how do we do that? Lines dot filter, and what was the name of our filter? Start with a filter. Start with a, and I can say filter. All right. And only a. You can see that. Now if I say only a dot take 10, it's going to run my filter, this filter against each element of lines. It will check against each element and only put the result into only a if this filter returns true for that element. So what does it say? It says that index out of range. All right. So we might have to improve our code a little bit. Okay. We might have to say if line, if line, if length of line is greater than 0, less than equal to 0, we can say return false. Okay. Return false. We are just doing one more level of check, that if length of a line is, all right, now it won't give an error. We can say start with a filter and we can check with this. All right, only a, and we can say only a dot take 10. Now it will only leave, it will only give the strings which are starting with a. Now you can see that it has returned some things like here you can see a Arthur, adventure, as, and a show, and what else? You have a man. So basically, it did the job really well. Are you convinced? So if you just want to keep some elements of an array, you use the filter. You use the filter if you want to keep only some elements of an array. If you want to translate one array into another, you use map. Otherwise, if you want to generate more number of elements from an element, then you do the flat map. Okay, you do the flat map. Let's say right now each element of an array is the line. We want to convert it into one word per, we want to convert into words. So we can use flat map and split the lines into words. Okay, so we can say words. All right, we can define our function called mySplit, and whatever line we give it, it'll, it'll simply do return line dot split. Okay, so now you can see that if I say my split and I'm saying Sangiri, it should return me an array. Do you see that? Now we can use this to split the lines. We can say words equal to lines dot split, lines dot flat map. Okay, so there is a difference between map and flat map. Map is used when one element is being translated to another element, and flat map is used when one element is being translated to multiple elements. Okay, so we can say flat map and mySplit. S has to be capital. Now we can say words dot take say 100. And you can see that the lines are broken into one words such that this new RDD called words. If you see, the words is nothing but an RDD. This RDD is basically a array of words. Good. So this is how the transformations work. When you want to do the translation of one RDD into another without bringing data the back to the console, then we call it a transformation. Okay, transformation is something which translates one form of RDD into another. Then there are other there are many transformations. There are join, there are reduce, there are union, there are sample, and so on. Have a look at it in the documentation. All right, now another form of functions, another kind of functions which are available on every RDD is actions. Actions, just like pig, when we were using pig, unless we said dump, or unless we said store, nothing happened. In the same spirit, unless you execute an action, nothing happens. So the action which I have been using it so far was take. Take was an action which made things work. Unless we said take, nothing happened. If you see, unless we said word dot take, nothing happened. The moment we said word dot take, it started computing. All right. So that was actions. Now there are many kinds of actions. One is reduce, other is count. Okay. Reduce, count, take, and so on. All right. So reduce considers each element of an array as key value tuple and then groups it and then reduces it. Okay. If you want to get all the data from all the nodes and dump it to the local, we can use collect. If we just want to count, we can do count. Or if we want to run reduce function, we can do the reduce. Reduce function is something like a combiner. Okay. The reduce function, whatever function, it only accepts the functions which accept two argument. This fu and c need to have two argument and should return a single value. And reduce functions basically reduce two values into one value, and these functions are called recursively on the whole RDD to convert the whole array into a single value, such as sum, such as count, and such as min or max. Okay, they have to be cumulative, commutative, and associative for parallelism. Kind of, it's a map reduce, but broken down for modularity. That's correct, Matthew. So, are you with me? All right. So let's say we have got this nice words, or let's say we had line lengths, right? We had line lengths. We had line lengths. Now we want to sum up all the line lengths together. Okay, if you want to sum up all the line lengths together, we can use a function called sum. Sum takes two arguments uh, and returns no, sum is not a valid, so we'll have to define our own sum function, my sum x comma y, and it will simply return x plus y. Okay, so we can say my sum 3 comma 4. Okay, and now let's try to apply this sum on line lengths. ll dot reduce, and I say my sum. Now this my sum will basically sum up all the line lengths. And did you see it did it really fast? So this is the total number of characters in this file. Sum of all the line lengths. All right. You might be wondering that this function called mySum had only two arguments, while LL has so many elements, around few lakhs of elements, and how did it happen? So it took two elements. So the way a reduce function is applied is little tricky. Just like a combiner, it is applied on two values at a time to give you the results. Let me show you what exactly is happening, and let me increase the font. Okay, so you can see, right? So imagine that if you were using on a single machine, so when we said line lengths, it gave us line lengths of each of these elements. All right, and when we sum it up, can somebody quickly tell what is the sum length? I think it's 62. The Okay, so we can also use Python to give us the results. It's not copied. Yeah, it's copied. You can see it's 62. So I use Python for my even the normal computation. All right. So here the line length, we are trying to compute the sum of all the line lengths. Okay. So in first transformation, we converted into line lengths, our lines, and then we summed it using the reduce function. All right. Now What exactly is happening in on what exactly is happening in case of Spark? So this big lines, which you think of it as a single line, it's actually on multiple node 1, node 2, and node 3. Okay, and the moment we said line compute, give me line lengths, it computed line lengths on the same node. Okay, so, and the next, when we said reduce, so it first computed the summation of the two elements, which is 20, and then after that it again executed the sum function and it gave us 24. While in this case it was on not needed. And then on node number 3, line lengths basically got summed up into 24. Now on the driver node, all these three values 24, 14, and 24 were carried to the driver node. Driver node is your console from where you're launching all of this. This is what is internally happening. So line lengths were computed, and then again two values at a time, it uh, aggregated, and it resulted afterwards into 62. So how many times your sum function was called? Sum function was called 1, 1, 2, then there was no need here, 3, 4, and 5 times. Total number of 5 times your sum function would be called for this kind of array, for this kind of distribution, and you will get the line length. So did it make sense to you? Now this reduce function or computing the line length is distributed. Why? Because line length computation is happening on each node separately. Similarly, whatever reduction could happen on each node, it happened on each node. Okay, so here the combiner and the reducer both are the same thing. So on node 1, node 2, node 3, the reduce function is being run, and the summary is being sent again to the driver node, where the reduce function will be executed and resulting in a single value. Did I make sense to you? Matthew's question is, what decides what goes in which node? So that's a call which is taken by Spark, and it's basically based on data locality. Okay, the data which is being so if you have the whole cluster installed parallel to Hadoop, then it will try to load the data on the similar node. Okay, so basically the idea is to have data locality. Make sense to you? All right. Matthew's question is, so does it use name node and job tracker? Yes, it does. Instead of job tracker, they call it resource manager now in Hadoop 2.0. So it uses Yarn's resource manager and the name node. All right. Good. Let's take a 10 minutes break and come back at 8:45. Matthew saying, but standalone, it doesn't have Yarn. Yeah, it has its own system. In those cases, it basically loads everything locally. All right. All right. Let's take a break for 10 minutes and come back at 8:46. All right, should we start now? Is everybody in? All right, let's start then. Leonid and Webhub. So we just talked about how the data is loaded in Spark in the form of array, which is distributed on multiple machines, and how we can run our choice of code on top of RDD, either in the form of transformations or actions. All right. There's an additional construct which is provided by Spark, which is called broadcast variable. If you have to send some piece of data to all the nodes which are running Spark, okay, which means you want to take this, you want to replicate this data on all the nodes that have RDD. Okay. In those cases, you can use broadcast variable. You can say SC is the Spark context object provided by Python. We can say Python by Spark in provided by Spark into Python. So we can use sc.broadcast any object or an array of object, and then we can use this object using broadcast var.value inside our logic. All right. Similar is the case of accumulators. Accumulators accumulate data continuously from all the nodes. If you have got this big RDD which is running your Spark applications and you want to gather the statistics continuously, then you can use accumulators. So your Spark application or your transformation or action can can write to the accumulator by saying accumulator.add this, add that. And that will keep on adding and the results will be gathered at accumulator. Okay. The only thing to keep in mind is since accumulation is happening from multiple machines, there is no guarantee of the order, which is quite obvious that when multiple people are writing, there is no guarantee in which order these results will be. Okay. So accumulators are something for gathering data continuously from all the nodes, data as and when it's happening. All right. So that's accumulation, and it's a quite a useful construct, specifically for reporting the progress of your application or for reporting, for basically giving out logs or other information. Spark's accumulators can be used. All right. All right. Here is the full-fledged here is the full-fledged word count example. So you can see here we loaded the lines into this particular variable. Then we defined a function. Then we defined a function. All right. So first we loaded the lines into this and then we defined a function called lines to word which splitted our records by a particular separator, and afterwards when we have converted this into one word, uh, into an array of words. Just a second, I'll close the door. Okay, so here we are saying first we converted lines into word by executing this as a flat map. Okay, afterwards the second step is to convert each word into a tuple. Okay, so I'll try to describe the process, what's going on. So let's say this is good, comma this is bad. All right. let's say these are the two lines. These are the two lines when we loaded, or let me start with the text file. Okay, so let's say there was this text file. There was this text file, and it is start. Our program is starting from here. Okay, so this is our input text file, and in the beginning when we said lines equal lines equal to this, so lines is actually okay this. All right, this is our big.txt file. This is our big.txt file, this one. And when we loaded it, the lines as an RDD is basically an array of lines. Okay, everybody with me on this? So we are saying lines equals to load this file, and it will looking like this inside. Next is that we execute this function. Okay, as a result, what would happen? We executed this function. Okay, as a result, each line would get converted into words. The words which is a new RDD will be looking something like this is comma good comma bad. All right, this is words. The moment we say split the lines by space and sorry, this is good and this is bad. All right, this is how it look like. Now Matthew's question, why is it that we don't have to pass an argument to lines to word function? Yes. So what is actually happening? That's a very good question. Probably I think I should answer it. So here the question from Matthew is, why don't we have to pass the argument here? So lines to word although is taking argument here, but here it's not. Okay. And you know why? Because we are telling this function called flat map, we are handing over a pointer to the function. We are handing over our function definition. And inside the flat map, what is it that is going to do? It's going to take your function and it will first execute internally. This is what is going to happen. It will first execute your lines to word on this. Okay, and then it is going to execute your function on this. Okay, on each element of an RDD it's going to execute your function. If it has a million elements in RDD, it is going to execute your lines to words a million times. Make sense to you and everyone? All right, make sense? I was trying to answer to this. So words will basically be equal to this. I'm just trying to, trying to explain with example. Yes, that's correct. So if lines here were a million, there were million lines, then RDD will be a million array element. That's correct. What's the date today? Today is 30 August, and we call it 25th July 2015 and 30 August. Make sense, Vaibhav? So this was our big.txt. When we loaded this file, it became like an array. Lines is an array of each line. Then we split it into words by executing a map called flat map, by executing a transformation called flat map, which converted it into something like this. All right. Next is something which is not very intuitive, which is this. Okay. So what exactly are we doing here? We are saying words. Okay, we have already done that. Yeah, like this. Okay. Now what are we doing here? We are converting each individual word into a tuple. Tuple is like key and value. So it will become something of this sort. When we run this map function, it will transform each element into a tuple. Something like this, comma, 1. That's what we are doing, right? Here you can see 2kv is basically taking a single word and returning a tuple. So each element is becoming like a group of two elements. First one is the word and second one is 1. So it's converting it into key and value. Value is 1 and key is the actual word. Make sense to you? Good? Good. Now, can so here is the question for all of you. So Webber is asking how punctuation mark be handled like dot etc. They will get attached to the word, correct? So if in a big file there'll be punctuation marks and also capitalization and all that. Now how will you clean it up? Okay, how will you clean that up? So anybody, any suggestions? Where will you clean that? All right, Leonid. Okay, I'll answer your question in a minute. So, so you can actually, Vaibhav, you can actually do it anywhere. Whether when you are splitting into words, here itself you can say line dot replace anything, anything which is not 0 to 9, capital A to Z, and small a to Z. Okay, you can do that. You can use a function called, there is something called re.sub, which substitutes one with another and so on. Okay, using this we can clean it up here as well. We can also do to lower, you can say lower, and do the split afterwards. Make sense to you? All right. So Leonid's question is, this way here, in this particular way, it's creating two elements. No, it's not creating two elements. It's only creating one element from one element. This is a single element. Okay. This literally also, this is a single element. Is a single element. Good is a single element. And so is this tuple is a single element. This tuple is a single element and so on. Make sense to you? Yeah, we can also split on punctuation. That's correct. While splitting, we could also give an array of characters and do that. Good point, Vijay. Hi, Vijay. So Vijay has, I think, recently joined. All right, good, good. All right. Now, so you can see that we are doing stepwise. Now there is something interesting, which is reduce by key. That's an action. And what we are going to do here, we are first going to define a function called this. Okay. And what is going on inside it? Let me explain to you. So at the end of day, we have prepared our key value pairs. Okay. Now we can do the reduce by key. Okay, when we say reduce by key, it is going to do group by and then apply an aggregation, just like your SQL. When you say group by something and you provide a aggregation function and the key, here when you say reduce by key, it means automatically the first one in this tuple is the key and second one is the value, and on this second array of the second value, for each word it is going to execute your sum function. All right, so it's going to be like this. So when we say reduce by key, what is it going to do is, you can think of it like this. Let's try to do this, comma, summation of 1 comma 1, right, 1 comma 1. Let me, okay, so it'll be this comma summation of 1 comma 1 because of, so this is not there, and then is not required here. We can also say sum 1 comma 1. Okay, and similar is the case with good. All right, so this 2 is 2, good 2, and bad 1. Sorry, good 1, it'll be 1 only, not 2, it'll be 1 only. Okay, so this way we'll have our summation. So now we can have a look at it, whether it works or not. Let's go stepwise. We loaded the data. All right, we loaded the data, then we define this. And what is wrong with it? All right, now let's do the flat map. Now if you say words.take, you will have a clarity as in what's going on, right? And then you can do things like, after this, you can define two key value. If you say two key value, good part about this command line is that you can quickly test your all functions, whatever you are writing. Okay, this way your confidence and your speed is really fast. Okay, now if you try to test sum, whether sum is working or not, you can do that, and then you can do the wc dot take 10. Now it's doing the computation. So it has done the computation for you. You can see that. So Spark Java does not give you the command line. Spark Java instead lets you write the code in Java, compile it, prepare the jar, and then submit the jar to Spark. Not really. Spark Scala, you can do that. With this Scala, if you are working with Spark, then you can do the same thing like this console. All right. So I hope this was clear to everyone. All right. Now you can also save it somewhere. Okay. You can also save it somewhere. like saying w.save.txt, and you can say spark 25 July. It has saved it. All right. It has saved it into our HDFS. As Giri word count will be there. Okay. You can see as Giri, and then there'll be something called word count. Under that, no, it's not there. Is it there? It says student as Giri output word count. Okay. Word count output, word count output. Is this the one? You can see that it has generated the two reducers instead of one. All right, it has done the job. For space, for blank line, there are these many blank lines. Good. Now your task is to make it little bit more simpler in the terms of cleaning up this data by making it lowercase, removing the special characters. Webhub, can you do that? I'll share this text file. I'll try to share this text file, as well as the code is also available in slide number 10. Yes, with regex you can do that. All right. So try doing the cleanup work. I have also written another piece of code which utilizes the accumulator and broadcast. You can have a look at this also. All right, in order to understand. Great, great. Now the next thing is Spark streaming. So as I was telling you that Spark can also be used for, because if you just observed the rate at which Spark was doing the data churning was really faster. It was giving us the results in really faster manner and immediately. We did not have to schedule things, wait for data to be written in HDFS, and then read it back. Okay, so even if you have multi passes, you don't have to worry about the whole process to finish. If you remember, in case of map reduce, if you have two phases of map reduce where second phase is taking input from the output of the first phase, the the process was really bad. Okay, it was slow because the focus there was more on fault tolerance rather than getting the results immediately. So first phase of MapReduce would write the output into HDFS, then second phase will start reading the data from HDFS. Now writing to the disk, and that too in a network, is a very slow process. Therefore, that's not suitable for lots of fast processing. But luckily, Spark was something which can be used for real-time processing because you can persist the data in the memory. Okay, and what does it mean by stream processing? Imagine this: at every point of time there are users who are taking some actions. Okay, and is being pushed. So generally in an organization, for example an e-commerce firm, when users are placing orders, these orders are being pushed into a organization wide queue from where various services can take the event. They can consider anything which is coming, they can read anything which is coming in the queue and take an action. Okay, so the way we have event bus, a queue can also behave like an event bus, and this is quite a successful mechanism. We have at Amazon we had something called SQSQ, which is also available for public, and queue as a construct is very powerful and useful for an organization. Okay, so and queue is very building a queue has been quite a as of today, Kafka and these 0MQ are really powerful queues. We have used 0MQ and Kafka both. So these are like big data pipes. The data keeps, all the applications are pushing data into these pipes, and on the other hand, lots of applications are reading from the same pipe. Okay, so when the data is coming into these pipes, your objective generally is to process it really, really quickly. You don't have to keep on waiting for, you don't want to make that queue wait on you. Okay, so generally you will run hundreds of services, not generally, in some cases when there are a lot of demand, you will run your services on maybe 10, maybe 15, maybe 100, and all of those services will have the same piece of code and will read the data from queue parallelly without without doing the duplication work, meaning one object is not being processed by multiple processors. So uh, these queues duty is to gather data from all the applications and keep on expiring data after some time. On other end of the queue are your listeners, which you generally write on multiple machines, and these processors keeps on reading data from these queues and process them. Okay, so this is called streaming mechanism, because the data is coming at very fast. And so for streaming, when people realize that Spark is able to do things really, really fast, they wrote a wrapper on top of Spark to do the Spark streaming. And how does it work? It basically keeps on taking data from queue and keeps on pushing that data as an RDD. Okay, zeroth element in RDD is the data that was received at zeroth t plus 0 time, and then the next element goes into next element from queue goes as next element in RDD, and so on. So at the end of day, whatever data you are receiving from queue, you take maybe 10 seconds data and push it to RDD, do the computation at RDD parallelly on multiple nodes, and whatever are the results, you save it. So this is called streaming, um, stream processing using Spark. So Weber's question is, so the Spark, it did not put minus R. Yes, that's correct. It did not put minus R. It also did not put minus M into the file name. Good observation. If you see part 00, instead of part M dash 00, it has put only part. Yes. All right. So yes, Spark streaming. So this is what happens in Spark streaming. And when we say Spark stream processing, it means we will convert our input data into batches of input data. Okay. On one hand, you are receiving 1,000 requests or 1,000 packets per second. The output of stream processing is, this is broken down into batches, maybe 10 seconds data, okay, and so on. So workflow is, Spark streaming receives the live input data streams, divides the data into batches and pushes it into RDD. Now Spark engine generates the final results in batches. All right. So for this, it basically provides you a class called D streams. D stream is basically a continuous stream of data. Now, so it basically breaks down the data into this format. So data from time 0 to 1 goes into RDD at time 0, time 1, and data from time 1 to 2 goes in RDD at time 2, and so on. Okay, so multiple windows of data becomes a single window, multiple windows of data becomes a single data. You see, multiple data at various timestamps in original will become single element in case of window operation. And this philosophy of converting the data, milliseconds data into bigger batches is all called stream processing. All right, let's take an example here. Vijay's question is, doesn't it not have to lock the RDD and stop increasing the size of RDD to do any computation? No, not required. Okay, RDD can be flexible enough. The locking happens for a fraction of time. When the map function is getting executed, only then the locking happens for the fraction of time when map is being executed on that particular element. Good question. All right. Now, the way you will run your Spark streaming is you basically will connect to the service which is spitting out the data and listen to the data that's coming in. So here we are connecting to localhost at this port to read the data continuously. And once the data is arriving continuously into dstream, you can run flat map just like the way we did earlier, and then you can form the pairs on that particular window, and then you can do the summation by doing a reduce by key, and then you can do the collect. Basically, the way it would result is, for you for you the data from 0 to 1 second will serve as a single data set on which your map reduce will apply and will give you the word count on that time. Okay, so you can see that your processing is happening, you are processing each batch instead of the whole file in a single shot. Okay, if you convert any stream processing into batch wise operations, then you have solved the problem. Okay, or window wise operations, if you convert the data with your problem into something like a window operation, then you have solved your streaming streaming requirement. All right, there is another tool for streaming which is called storm, which was dedicated tool for doing the stream processing. It's a distributed reliable system. It's a dedicated cluster for doing the stream processing. It's very reliable for very unlimited amount of data which is coming in. It can be used with any language. It can be used with Java, Python, any language. Okay, it's it's really fast in the sense that it has been benchmarked to process 1 million tuples, 1 million key value pairs per second per node. Now you can think of how fast it can perform. It's scalable, it's fault tolerant, it guarantees your data will be processed. It integrates with queuing and database technologies. Okay? Now, Spark and Storm are also competing in a way, but Spark is more like a general processing system, while Storm is dedicated for stream processing. Okay, Storm is being used by real-time analytics, online machine learning, and distributed RPC and ETL and continuous computation. Okay, now with respect to comparison with Spark, the storm looks like this. The storm's model is record at a time, while Spark streaming is mini batches. The latency in case of storm is sub-second, while in case of Spark it's few seconds. In case of storm, there might be duplicates, but at every record, so there might be duplicates because of overlapping windows in case of Storm, but in case of Spark, every record gets processed only once. Okay. The Storm was found at Twitter. At that time, Twitter was called Backtype, while Spark was founded at UC Berkeley. Storm was implemented in Closure, while Spark was in Scala, and so on. Okay. And the production and support for Storm and Spark, okay, was for Storm, it has been well supported, okay, well supported, well proven, and it's supported by Hortonworks. But while in case of Spark, it's supported by a company called Databricks. It's not mentioned here, but Databricks supports it. Sorry, Hadoop distribution includes Storm, and Spark is included by Cloudera, and now Hadoop Hortonworks is also including this. So Databricks is providing supports, and Spark can run on Mesos and Yarn, while Storm can only run on Mesos. It cannot run on Yarn. So if you have already a Hadoop cluster and you don't require millions of record per second to be processed, then Spark is your solution. All right. So Vijay is saying the way we have to lock a table in case of aggregations, we can also do we have to lock does our data sets get locked when we are doing processing? So the locks in case of Spark are only for very brief period of time, so that while we are processing, somebody else does not delete it. Now, Webhub's question is, so no support for Storm? Yeah, there's not much of a support available for Storm. All right. Any questions at this point? So your best bet would be to use Spark's streaming engine for processing data which is coming at a very fast rate. Yes, that's what I was saying. Uh, it was not included. Matthew's question is that we are using Hortonworks, but we are still using Spark. The thing is that they are not shipping by default. But although now they have started supporting and started shipping Spark along with the existing systems, okay, right now this Spark has been installed by us. It was not there in the default distribution. Okay. In summary, Storm has been in production much longer than Spark. Okay. Second is there is a dedicated company for Spark called Databricks, and it is compatible with Yarn. So unless it's really required, as in unless you need to process a million record per second, you don't require Storm. Yes, I installed manually, Matthew. As I told you in the first slide of Spark, second or third slides of Spark, where how to install, basically unzip and run and configure it to run on Yarn. All right. No, no. All right. Any other questions? Now we'll just go through a brief of few more databases. Very brief. It's like one paragraph dedicated to each. This would help you decide which database to use when. All right. All right. Let's start with NoSQLs such as Redis. A Redis is a in-memory database. It's an in-memory database which is also distributed. It's great for processing the data which is rapidly changing. So Redis provides you an in-memory storage. Also, the data whatever you are putting into the memory is also saved into the disk. Therefore, the complex structure can be very well processed on Redis. Okay, and if you have to do lot of write operations at a very fast rate, Redis can also be very well used. All right. For rapidly changing data with foreseeable database size, which should fit mostly in the memory, to store real-time stock prices, real-time analytics, leaderboard, real-time communication, and wherever you have used a tool called Memcache, you can use Redis really well. All right. Next is MongoDB. MongoDB is good when you have to do the dynamic queries. If you prefer to define the indexes, not MapReduce function, although MapReduce is available, if you need good performance on a big DB, okay, MongoDB is basically the way MongoDB is storing data is in the form of JSON object. Every row, the way we define row in traditional databases, there is a object instead of a row, and this object is formatted in JSON format. If you wanted CouchDB but your data changes are too much and it's filling up the disks, so for most of the things you would like to do with MySQL or Postgres, but you have predefined rigid schema which is holding you back. So in all those cases, you would like to go for MongoDB. Okay, MongoDB can also be used in a smaller data environment where your requirement of storing data into objects is far more as compared to requiring the data to be stored in RDBMS. All right, so that's a MongoDB. Now is Cassandra. Cassandra is almost like normal SQL database, but very huge. Okay, when you need to store data so huge that it does not fit in fit on one server, then but still you want a familiar interface like SQL, then you go for Cassandra. Cassandra provides you an SQL. Although Cassandra and HBase are good competitors, head-on competitors, okay, but I would personally prefer HBase over Cassandra because Cassandra is for Cassandra I'll have to again establish a setup, another round of installations. In case of I mean HBase, you already have the installation for Hadoop. Okay, if you have already have installation for Hadoop, then you don't require Cassandra much. All right, Cassandra was started at Facebook and is really well done. I've used it and contributed the some patches also. Next is HBase. We have all talked about HBase. And it's basically two-dimensional join-list table requirement. If you have that, HBase is probably the best solution available. Accumulate is big table with cell level security. A hypertable is basically a smaller and faster version of HBase. All right. So let's go through the project also. So was I able to answer your questions on other topics? Do you have any questions on Cassandra, NoSQL, MongoDB, Redis? No? All right, let's go through the project. That should be good enough. All right, so let's open the project discussion part. So Vaibhav's question is, when would you use Cassandra or Solar if HDFS is not requirement? So if your HDFS is not requirement, then and you need to store a lot of structured data in form of columns and rows, then Cassandra is a good bet. Okay, then Cassandra is a good bet. And Solar is for searching. Okay, Solar is for searching only. So Solar is a service to which you keep on submitting the text and it keeps on forming the index. And when you hand over the text, you also provide the key value pairs identifying the text. Okay. Various attributes you keep on handing over to the Solar. And once you're done with that, you can at any point of time search and it'll give you the results. Solar is specifically for indexing, text indexing. All right. Now let's go through the project. So the objective of this project is to do the sentiment analysis, and this is not a very difficult problem. It's a fairly straightforward problem. Okay, so first I will suggest one simple approach, and then you can take any of these 6 deviations which are listed here. We'll come back to these deviations. Let's just go through the project first. All right, it's quite straightforward project and it should not take much time for you to finish. All right, all you have to do is take the do these steps, take the screenshot. Once you are done, then send me the name of the DB. If you are doing it locally, send me the database itself. If you are not using the cloud labs, send me the database. Okay, along with the screenshots. All right. So as we had already told that part of the sentiment analysis, I mean, meaning of sentiment analysis is to find out whether people are talking negative or positive about you. What is the overall sentiment in public? And we will do the sentiment analysis of a movie called Iron Man, and we'll do the data. We'll get the data from Twitter. Okay. For the sake of this exercise, we have already downloaded the data and made it available here. Okay, so you can see that there are 3 folders. One is tweets raw. Okay, it contains the gzipped version of all data. Second is time zone. Time zone is a tab separated file. Now let's first take a look at what does it mean by tweets raw. Do you see that? Let's pick up one object out of it till here. Format it using JSON formatter. Leonid is asking which screenshots. When you are doing this project and you are preparing the reports, you send those screenshots. Okay, so let me show you this. So this is one tweet. This is one tweet from this whole page contains the data about a single tweet. So the tweet text is Iron Man 3 crushes open day records in China, blah blah blah. Okay, and there are these attributes or the metadata of tweet. Okay, the id, there is an id which identifies each tweet. So if we group by, if we basically break down this text into words and then find out the sentiment of each word, whether the word is negative or positive, and then sum it up by again grouping by id, then we should be in a good shape to find out the sentiment. Okay, so is this okay? So out of this full tweet, we only require text, date time, and id. Okay, text, id, and date time. Date time for finding out the country name. All right. So here you go. So this is what our data looks like. This is the input data. There are many such files and we have to process all of those. Okay. As the next step, once you have this data quickly available, you go through go through the go up and go in Hive. You see, out of this, these two are of importance. This is our JSON survey. It will be required to parse the data, parse this data, okay, and convert that into something which can be processed by Hive. So if you say hive ddl.sql, you will have this data. Yes, the task is to process these tweets and find out the sentiment. So let me again take a step back. So above we had Hive and not Hive, we had data in which there is tweets raw. This is Flume data, which downloaded these tweets for using Flume, and these are gzipped. So when we load this using this particular JSON in Hive, we should be able to easily form the object out of it. Okay, and once we have formed the words out of it we will compare each words against the dictionary and we'll find out whether the word is negative or whether the word is positive. Okay, we'll do a join with this dictionary table, and then we will quickly analyze whether the words are negative or positive. All right, so the most important query out of this is this one. So we load the JSON, then we create an external table which represents tweet raw using the row format as JSON survey, as in we are utilizing this particular JSON to parse our JSON data provided in tweets raw, that gzip data. That's we load the data in the form of this table. You can see the complexity of this table. We load the data into this table. And once we have loaded this data into this table, external table, we load dictionary also into one table, and we also load time zone map into one table. Next is that we clean up the data, find the countries, and after that we further clean it, and then we join it after we have broken the word, exploded a sentence into one word. And once we have done that, we can compute the polarity using this kind of a logic. We are joining our data set with dictionary on word. And then if the polarity is negative, we are giving -1. If polarity is positive, we are returning 1. If polarity is 0, we are saying otherwise we are returning 0 as polarity. Okay. And once you are done with the polarity, you group the data. So we found the polarity of each word in each tweet. In each tweet, each word, we found the polarity. Now we can group by the tweet, we can group by the tweet ID, sum up the sentiment, and we will have clear picture on whether there is a negative sentiment or positive sentiment. So we will sum it up. Okay. And once we have done with summation, we can again translate our 0 into positive and um, um, 1 into negative and so on. Okay. Then once we are done with this, we will connect to Hive. There is a Hive server to which we can connect from any of the tools, maybe your Tailend or maybe your other other tools using which you can connect directly to our Hive server and display this particular table called tweets bi into your Excel or any other visualization tool. Okay, so all the files you have to do it for all the files, Matthew, not for one. Okay, you just have to process the whole folder. All right, so once you have done executing Hive and your tweets bi table is available containing your data, then you can move ahead to install the Hortonworks Excel driver or some other tool using which you can do the presentation. All right, there is a steps written here on how to generate the chart. Please follow this and try to do that. Otherwise, if you are using your own tool, you can use that also, which is completely okay. So Weber's question is, does the files need to be unzipped first or directly read? Directly read. Okay. HDFS supports compression at a very lower level. So you, while reading the file, it can tell HDFS to unzip it by itself. Okay. So Leonid's question is, so to complete the project, you just have to follow the step by step. So if you just want to give it first shot, just run it whatever is here. Then once you are done and confident, then you can take a slight deviation and do it in the way you want it. Okay. So Leonid is saying there is really not a whole lot of decision in the project. That's correct. That's correct. But that will give you a minimum kind of lift. As in, once you have finished, say you have finished building the recommendation. Once you finish building the recommendation, then you will have enough of confidence to take the deviation, put your decisions in place, and then make it little better, or or take the completely different approach. All right, let me show you the different kind of approaches. But before that, I would like to answer Matthew's questions. What type of graph should the results be? If you go down into this, you will see these beautiful graphs. So one is like on the map. On the map, we are showing uh, as color negative and positive. Okay. First one is in the case of a pivot table, and so on. Okay, there you can have a look at it. All right. Now there are few deviations. Right, Leonid, that's correct. This is minimum requirement. All right. So there are many deviations which our students take, and they come up with their own brilliant ideas. Okay. This is just a basic one, which gives them a kind of a starting point, so that they are not confused. Instead, they get more exposed to Hadoop and all its components during this project. Okay. So like for example, let's avoid this one for time being. Yeah. So instead of using pig, some of the candidates have done it using Hive. Sorry, instead of using Hive, they have done using pig. Okay. Or one of the candidate also worked upon using the natural language processing in and MapReduce in order to find the tweets, in order to find the sentiment of the tweet. Okay, based on using some algorithms from natural language process package. Third is using your own Flume pipeline to download the data. Okay, sometimes the data which I have provided, I've just provided you everything whatever is available. Some people want to download data in their own manner, and they start with a different movie rather than Iron Man. Okay, you can create your own project to download the data from Twitter. Sometimes you don't like Flume, you want to download data maybe from Twitter or somewhere else, you can do that. So there are many deviations possible. Instead of displaying data in Excel, some people go little more fancy and they do it in D3JS. D3JS is a very brilliant library, and it's worth spending a little time to understand the how to display the graph. Okay, you can use Tableau. There is a public Tableau in case you are not able to. Okay, in case you are not able to. Okay, in case you are not able to finish using. Uh, all right. If you're not able to install Hortonworks Excel driver, you can use Tableau's public database also, public presentation also. Okay. All right. So this is the public project. So finish this one. This will give you a good idea. And there are more approaches. The modern ways of doing the sentiment analysis includes a lot of machine learning and natural language processing in processing of this data. All right. This should be good enough for you. All right. Any questions for me at this point? The timelines for the project are mentioned here. So please submit the project by September 17th. Sorry, September 13th. All right. All right. Great. Any questions at this point? All right. So is that okay if I unmute you and we say goodbye? And so just Vijay, just drop me us an email at support@nobigdata, and we will help you in whatever we can do. Hadoop at nobigdata is also okay. Okay. So we'll try to help you in whatever possible manner we can. Over the, you just drop us an email at hadoop@nobigdata. All right. All right. So, all right, let me just unmute you. I've never done unmute all ever. Let Hi Deepak, are you able to hear? Do you have a mic?
Hi, yeah, hi Sandeep.
All right. So I hope you like the sessions.
Yeah, I liked it and it was a good experience and I have learned a lot and changed the perspective of big data. What I was thinking, it was completely different.
All right. All right. Great. I'm really happy. Stay connected and send me a LinkedIn request. All right. Stay connected.
Yes, yeah.
And in today's time, we even though it sounds like that we are saying goodbye, but you will keep on seeing my updates, and I'll keep on seeing your updates on LinkedIn. All right.
Yes, yeah. Yeah. Thank you, Sandeep.
Okay. Hi Matthew.
Oh, hello. How are you?
I'm good. I'm good. How are you?
Great, great.
All right. So I hope you were not bored in the sessions.
No, not at all.
All right. All right. All right. So, all right. Stay connected. All I have to say. And if you have anything else to say to me, you can say.
No, I really enjoyed the class, and you were a very knowledgeable person, so it's very good.
All right. Thank you very much, Matthew. And I really thoroughly enjoyed your questions. And all right, stay connected.
Wonderful.
Great. Uh, Hi, Vaibhav. Is it okay to unmute you?
Yeah, sure, Sandeep. Can you hear me?
Yeah, yeah, I can hear you.
Okay, yeah. Thanks, Sandeep. Thanks for the in-depth insight into big data. I'm sure I'll follow up with another session of yours because, unlike others, this was really knowledgeable and too many questions, which was a very good aspect of these classes and something I really enjoyed. So, looking forward to the next set of classes. Thank you.
All right, all right. Okay, great, great to have you, Vaibhav, in the class. All right, and all right, Vaibhav is also my classmate, and I'm generally very happy that my classmates have my classmates when they appreciate their classes. All right, and hi Vijay, is it okay to unmute you?
Yes, Sandeep, thank you. Yeah, it was a great course, and I'm sorry I had to skip out
Mm-hmm.
on Swati's courses from last time, from the
All right.
last session.
Okay,
And
okay,
if you
okay.
can convey my, yeah, I didn't get a chance to say goodbye to her.
All right,
So if
all
you
right,
could please convey my thanks to her.
all right,
And she's a great teacher, and she
all
did
right.
a great job in the last session.
Okay, okay, great. I'm really happy to hear that. And she's also one of the big data experts. She's a contributor to HDFS and Hive, and she's I mean she was the only one selected out of around 40 for 40 candidates for taking the class. All right, I'll convey your regards to her also. All right,
Thank you.
great, great. All right, Vijay. Yeah. All right, thank you very much, and stay connected. That's all I have to say. Bye bye. Bye. Have a great day.